2.5 years ago, if someone would have asked me about medical imaging, I'd be drawing a blank. I mean, as a patient, I know that, you take radiography and all these things, whether it's your dental or other parts of your body. But besides that, I had zero understanding of it. Today, if you look at the need to detect and characterize cancer in an individual has resulted in dramatic increase in the use of imaging in the last 20, 30 years. The field that I had actually zero understanding of has been in the industry for a long time. Clinic and imaging is actually today a routine part of diagnosis, staging, guiding localized therapy, and assessing the response to treatment. Cancers occur anatomically among surrounding normal tissues, including critical structures such as major vessels and nerves, and delineation of extent of malignant and non-malignant tissues is very important and super essential for planning surgery and radiation therapy. Now, cancers also have a morphological, physiological, and biochemical heterogeneity, especially if you want to study molecular biology, which is super important in understanding their biology, the biology of the cancer, and the response to the treatment, what treatment you want to give. The ability to explore and define this heterogeneity with modern imaging tools, and as well as serums and tissue-derived metrics, will enable and empower the personalized cancer medicine and patient care in the coming years. Imaging is diverse in that it offers an anatomical image of a mass on a computer tomography, which is CT scan, as you know, or a magnetic resonance image, which is MRI. A functional image of a disease status in a PET or positron emission tomography image of glucose metabolism, or microscopic image used during the classification of the histological type and grade. Imaging is applied at these multiple levels to understand, to help characterize, understand, and treat cancer. And there is a general acceptance that the advances in imaging are essential in order to fight against cancer. In the coming, this lecture, the industry sort of vertical lecture in healthcare will be sort of going into field of oncology, oncological imaging, especially with the advent of deep learning. We'll be presenting a bunch of physical principles underlying the most common imaging modalities and their clinical and research applications in oncology. We will look into various imaging technologies such as MRI. We'll look at single photon and PET, I just mentioned positron emission tomography, ultrasound imaging, and optical imaging. So it's going to be sort of a long bunch of series of lectures in letting you kind of, into this field. The way I got super excited when I started learning about this, when we first did our breast cancer project. This was almost 1.5 years ago. We've completed a bunch of medical projects in the last 2 years. I'm subscribing to a lot of magazines. Just wanted to show you, this is I still have to open this, Pathologist. So I've been using this for a while, not just this, and a bunch of other medical journals, and also some hardcore books. I'm not saying I'm an expert. I don't think I ever will be, but I think from from a computer engineering perspective, from machine learning perspective, I really want to be sort of want to be participating in this industry. Thankfully, we have a lot of sort of encouragement from all the medical colleges we're working with in Europe, and also we'll be announcing some really interesting ones in the Middle East. In these lectures, we'll try to kind of just go through into these techniques, things like, what kind of staining techniques you use, if you're using histopathological images or cytological images in breast cancer or other areas. And I hope sort of this gives you a bit of an idea of what we were going to be doing. So just kind of recouping back on these sort of tutorial series, what I'm trying to do is writing a book and all those things I was really trying to do, but it's just really impossible for me to sit down and write. I mean, I'm trying to run a bunch of startup projects. It's not like I'm an employee of some big company and just write a book. But so this kind of an idea is hopefully it's going to sort of help you, help me as well to to learn about the things that we're learning. Primarily, there are three things. So the first is, the deep learning and machine learning concepts, all the other things around, optimizers, activation functions, classifiers, overfitting, underfitting. So that'll be sort of like the fundamental of machine learning and deep learning. The second aspect is, AI for executives, where I'll share my sort of, strategy consulting and organizational development knowledge and experience, and add some interesting concepts there. And finally, the industry area, which is healthcare. So to start with, obviously there are more other industry areas which we want to get into. So hopefully this gives you a bit of an idea on at least the scene or the tone that I'm setting in trying to do these things in the coming months and years, I hope. And at the same time, continue to be a student and keep learning. It's all about sort of learning new things. We're not an expert in industry vertical areas, at least not all industry vertical areas. Healthcare is a big industry. It's a hugely deep, big industry. And if you can make some impact with machine learning and deep learning technologies and help with diagnosis and potentially also into some predictive, reliable predictive techniques, that we would sort of, at least I would feel that my purpose was served. So looking forward to seeing you guys, and hope to see you enjoy these lectures. All right. So you heard me talk about the medical and medical imaging and machine learning, and that is part of this series of industrial AI. So that's going to be this guy. And just to give you a perspective of what we are starting with is right now it'll be on Curae's company page, and we're starting with oncology, and then we're going to go into areas of medical imaging, as I just spoke, medical imaging. And soon enough, obviously, we're going to go into breast cancer. Then we're going to touch dental, and every pathology has its own challenges. And there are a couple of other new projects, endometriosis, and also obviously renal, which is kidney, bladder, and a bunch of other pathologies. So basically, just to take a look back at what I mean with this lecture series. So basically, this guy the focus is here to get into the fundamentals. So everything that we will talk about here will be, the optimizers, the activation functions, classifiers, everything. Obviously, computer vision, stuff like CNN, and a bunch of other interesting techniques in computer vision, and NLP, for whatever that includes, RNN, and all the modern NLP techniques. In AI for AI for executives, we're going to focus on strategy, AI ML projects, real world projects, and essentially sort of execution, and setting up your AI ML labs. Oh, my handwriting is pathetic. And then this is the industrializing AI, which is going to be AI machine learning, which is where we're going to touch Kurai. So we're touching Kurai right now, but obviously there are going to be other areas like climate AI, policy AI, and all these areas we're going to touch one by one. So for these lectures, just keep a watch on the Kurai page, and on the Kurai page we'll keep updating. I'll go into deeper areas of medical imaging and machine learning. So talk to you guys then.